Alright, so obviously I'm not there today, so tonight's homework is going to be number 8, and you have a little extra time to do anything left on your IA, but honestly, there should be nothing left. What I wanted from you was essentially, what do you think you need to turn in for your IA based on what was given to you and the task? So use the checklist and then also go through and make sure, did you answer every question that they asked in the task? And then on one of the days this week, we'll talk about exactly what you're expected to do, because I can almost guarantee what you've done is not quite enough. Okay? So I'm going to go over logarithmic functions and equations. If I make mistakes, watch the video for a little bit longer. I may correct them. But if not, someone come up and just pause the video and make the correction, please. All right, here we go. So the first thing I'm going to do is talk about the exponential function. So y equals e to the x. And its inverse is actually y equals ln of x. Why are they inverses of each other? Because I can do the proof, which is y, let's call this f, and let's call that g. We can do the proof, f of g of x, which would be e to the ln of x. Cancel those and we get x. G of f of x is equal to ln of e to the x. Same thing, e and ln cancel, give us x. So that's the definition of an inverse function. It's also a proof. The other thing we could do, take f of x, y equals e to the x, and switch the x and y's, and then solve. And when I solve for this, you probably have seen this before. I'll explain it in more detail today. But there you go. So they are inverses of each other. Next thing I can also show you is graphically. Oopsie, wow, that's a really thick line. Graphically, I'm going to take the point 1, 0, and that will be what I use, or 0, 1. Wow, 0, 1, and that's y equals e to the x. 0, 1, switch the x and y's, you get 1, 0, and that is the ln of x. And how are they related graphically? They are reflections across the line y equal to x. So there's my reasoning of why they're inverses of each other. Now, exponential functions are y equals a to the x. Logarithmic functions are y equals log base b of x. If you see a function of just y equals log of x, then in the math community, we know that without a base written there, the base is 10. And the other one where we might not see a base is ln of x, and same thing, in that case, the base is e. All right. So I'm going to show you what the log actually means and how to calculate log values. To start off, let's just do an easy one. Log base of 7 49, sorry. Log base 7 of 49. So log base 7 of 49. So the way I do these, I'm looking for how much that equals, so I just put it equal x. We're going to talk about little base. That's a little base. All of these guys here are what I call a little base, and literally for that reason, because they're tiny. A big base would be something like e to the x. This is a big base. Or 3 to the x. This is the big base. So what I say is, if the log has been isolated, and the log is isolated because the 49 belongs to it, and the log is all by itself otherwise, then you can cancel a little base with a big base. So what does that mean? I'm going to use a 7 and raise the 7. It's 7 raised to the log base 7 of 49. And then I'm going to do the same thing to the other side, because that's what we do with equations. And so what I say, again, is that a little base and a big base cancel. When I do that, it also cancels the log, so we get 49 is equal to 7 to the x, so obviously 7 squared makes 49, so x is 2. So to verbally say what the log does, you're looking for what value or what power is 7 raised to get 49. So for each of these, we can kind of do them very quickly by saying, what power of 4 raised gives me 64? Then this would be 3. 4 cubed is 64. Let's see. Moving on. Let's look at log base 2 of 4 minus x squared. So if you want to do a domain, I want you to remember what the log function looks like. The basic log function, ln function, all of them look like this, meaning they have an asymptote at x equal to 0, and this side of the graph doesn't exist. So what does that tell us? It says that the log can't take anything inside of here that's 0, and you can't take the log of negative values. So really, you're trying to find when the inside of the log is greater than 0. Easiest way to do that, take the inside. And we do the same thing for even roots. We do the same thing. So if I did the function square root of 4 minus x squared, the work I'm about to do, same exact thing. All right, so take the inside, set it equal to 0. We get that x squared is equal to 4, x equals plus or minus 2, and then you're going to make a sign chart. And when you make that sign chart, you're going to be evaluating the sign chart using the inside, so the orange up top. So if I put negative 2 or 2 into the inside, it gives us values of 0. If I put in 0, it gives me positive values. If I put in 100, it gives me negative, and negative 100 gives me negative. And remember what we said, logs can only take positive values. So the domain becomes the values that are in between negative 2 and 2. All right. So some basic properties that you should know. Log base b of 1 is equal to 0. Log base b of itself is equal to 1. Log base b of b to the x is equal to x. And so what I'm going to just show you are these three using my nifty little base and big base. So if there's a little base and big base, they're going to cancel. And in this case, you don't cancel to 0, you cancel to 1. If you have log base b of b to the x, same thing. Those cancel, leave us x. B to the log base b of x, little base and big base cancel, leaving us x. So in this case, that first one, it's because it's b to the 1 power that works. All right, so evaluate the following expressions. These are all supposed to be ones that simplify really easily. So log of 1 over 10 is the same thing as log of 10 to the negative 1. And remember, if there's no base there, the imaginary base that you don't see is 10. Little base and big base cancel, so this gives us negative 1. Let's do one more. Let's do log of root of 10 equals log of 10 to the 1/2 power. Little base of 10, they cancel, the answer is 1/2. And then some of these are just really easy, meaning e and ln are bases of each other, they cancel, gives me an answer of 5. The ln of 1 you are supposed to know, that's just 0. In this case, ln of e is to the 1 power, so this is 1. Those are some basic, easy ones. Let's go through some more properties here. If you have a singular log and the inside is a product, you can expand. This side is called the expansion, and this side is the condensed. If you have a product, they expand to a plus or a sum. A quotient expands to a difference, and then this rule is where if you have a power, you can bring it in front and multiply in front with a scalar multiple. So we're going to use these these properties real quick to expand. So let's do one easy one. Let's do letter A, log base 2 of 8x. This is a log with a product, so the product can now become a sum. And then let's do one harder one. Let's do letter D. So log base b of x cubed over y squared. So that's a quotient, so I can turn that into a difference of log base b of x cubed minus log base b of y squared. And remember, these powers can drop into the front, so we get 3 log base b of x minus 2 log base b of y. So that is expanding, and now I'm pretty sure we'll probably condense. There we go. Let's condense the longer one here. So log base 3 of m plus, why am I rewriting it? That makes no sense. So let's do an easy thing. Let's move this back up. We know this is a sum. So if this is a sum, let's do that first. A sum condenses to a product. And then log base 3 of p squared. And then here we have a difference which condenses to a quotient. So mn divided by p squared. So that is condensing. Change of base, it's just a rule that we use in case you want to evaluate something like log base 5 of 2 in the calculator. Alright, so log base 5 of 2 cannot actually go in the calculator. Your calculator really only does a base of 10. I heard rumors that 84 pluses can now do different log bases, but I don't actually know if it's true or not. So that's where the change of base comes from. We can change bases by doing, and I remember it this way, the base stays in the base. So I do log of 5 on the bottom and then log of 2 up top. The other way you can change this base, you can also use ln. So same thing, the base goes on bottom, and then the other value, the actual big value, is up top. So I'm going to write that here. I prefer using ln, personally, instead of log. All right, solving equations. So you just want to isolate the base. So when I say isolate the base, anything that the base takes. So something like a to the u, this is considered what the base takes. ln of u, whatever this is in here, is what the ln takes, as long as there's no values in front or no values added in the back. There's nothing extra, then it's isolated. Isolated means when the ln and its inside are by itself on one side of the equation, or when the exponential is by itself on one side of the equation. So in this case, because the e to the is by itself, I'm going to take the ln of both sides. And it actually has nothing to do with the fact that the base was e. I always use ln. So, how is that helpful? Well, first of all, let's move that down. Oopsie. 0.075t, ln of e. Remember, ln and e cancel to 1. So we get t is equal to ln of 2 divided by 0.075. All right, next one. There shouldn't be too many of these. Solve for x in this equation. Same thing. I want to just double check. Is the base and its inside isolated? Yes, it is. And so I'm going to take the ln of both sides. So ln of 3 to the x minus 4 equals ln of 24. This can come down, so we get x minus 4 times ln of 3 equals ln of 24. X minus 4 is equal to ln of 24 divided by ln of 3, and x is equal to positive 4 plus ln of 24 divided by ln of 3. All right, let's try another one. You invested €1,000 at 6% compounded quarterly. How long will it take for the investment to essentially double? So the formula that we're going to use, I don't actually remember all the values, but that is the formula. So I'm going to start with the fact that the initial amount was €1,000. My rate as a decimal is 0.06. How many times I'm compounding quarterly means 4, and then we're going to do 4t. In this case, the value that I want to end up with is €2,000. So first thing I'm going to do is obviously divide by 1,000. You end up with 2 equals 1 plus 0.06 divided by 4 to the 4t. All right, so the value that you get is 1.015 to the 4t. And in this case, because I want to isolate the base and what it's taking, it's already isolated. I can take the ln of both sides. I end up with the ln of 2 is equal to 4t times the ln of 1.015. And then to solve for t, t would be the ln of 2 divided by 4 ln of 1.015. So I divided both sides by the 4 and both sides of the equation by the ln. All right, another example. So I wanted to show you this because I did put one on your, I think on your quiz, but in case you didn't get it, I figured I'd go through one of these. The bacteria rate is here. They want to know how long it will take for the bacteria to double. So bacteria to double in number. You can do a lot of different formulas. I'm going to use, what do I usually use? A is equal to P times 1 plus R to the T, because we're not compounding, and it's not compounding continuously, so that's the formula I'm going to use. In this case, let's call the initial amount P. If the initial amount is P, to double would be 2P. If I'm going to double, the R is actually 1, so it's 100% on top of the initial amount. Oh, just kidding, not 100%. What am I talking about? It's 0.023 to the T. So the question I usually get for this type of problem is, they didn't tell us how much we started with. What you'll notice is it actually doesn't matter. What happens is you divide by P first, so because you're doubling, the value that you set equal to is actually 2. So 1.023 to the T. The base is isolated with what it's taking, which is T, so we take the ln of both sides, that comes down. So T ln of 1.023 equals the ln of 2. Therefore, T is equal to the ln of 2 divided by the ln of 1.023. Alright, solving for x. In this problem, I think we have a few more left. So I've isolated the base, the log base 3, meaning there's no extra values added or subtracted outside of the inside. That sounds odd. So, to give you a contrast, if I had this problem, I would have to move the 1 first because the log is not isolated by itself. So that's what I mean when I say that, because it might be confusing. So now that it's isolated, the base is 3. I'm going to use a big base of 3 to cancel it, and I get 2x minus 5 is equal to 3 squared, which is 9. 2x is equal to 14, x equals 7. Alright, next one. So here, I like this problem because if you look, it's not isolated. There are 2 different log functions, so you actually have to condense that so that the problem can be done. And to condense a sum means that it turns into a product. Equals 4. So now I've isolated the log. So you're not even allowed to have 2 separate logs. This plus means that we haven't isolated it. You're allowed 1 log isolated by itself with its inside. Okay, so we get log base 2 of 10x minus x squared equals 4. The base is 2, so I'm going to use a big base of 2 to cancel the little base of 2, and we get 10x minus x squared is equal to 2 to the 4th power is 4 times 4, which is 16. So I'm going to bring the x squared to this side so it's positive. X squared minus 10x plus 16. The factors would be x minus 2 and x minus 8. So the values are x equal to 2 and x equal to 8. And I really should have mentioned this from the very first equation that I did. You should be checking if the solutions work. And what do I mean by that? You're going to double check the domain. And I don't want you to go through a really long process for this. In this case, we know that your x's have to be greater than 0. And in this case, we need, because that's essentially the equation you're going to end up solving. So set it equal to 0, you get 10. 10 would be 0. If I put in 11, it's negative, but over here it's positive. So I'm allowed to use values between 0 and 10. Those are the only values. How do I know that? Because the first log gave me that the x's have to be greater than 0. The second log gave me that the x's have to be less than 10, so the domain for this problem is 0 to 10, not inclusive. So if you look, x equal to 2 and x equal to 8 are both within that domain, so they both work as our solution. I'm going to go back and double check the one I did here. I want to double check 2x minus 5, set it equal to 0, the domain. X is equal to 5 halves. 5 halves is 0. If I substitute in 100, it's positive. Negative 100 would make it negative, so the domain for this is anything bigger than 5 halves, which is 2.5. And 7 is definitely greater, so this works. Alright. Last guy. We see that this is not isolated. It is a sum. So I know that I'm going to get the ln of x minus 2 times, oh my lord, this 10. ln of x minus 2 and then 2x minus 3 equals 2 ln of x. So what I'm going to do, I'm going to raise that up here, and you'll see why in a second. So this is the type of problem where if you look at the left side, it's the ln of something. Look at the right side, it's the ln of something. And because that's the case, you could essentially you could cancel them, but I'm going to show you the reason why. I'm going to use e to the on both sides. They cancel, so the actual equation becomes this guy. So we get 2x squared minus 3 minus 4 makes minus 7x, and then plus 6 equals x squared. Bring that over, which makes this problem much nicer. And we get x minus 6, x minus 1 equals 0, x equals 1 and 6. Let's check if both of those answers work. So let's see here. This one's kind of easy. X has to be greater than 2, and this one is x has to be greater than 3/2. So the domain for this guy is that in the end, x has to be bigger than 2, because 3/2 is actually less than 2. So the only solution is 6. All right, I believe that's the last one, but let's double check. Yep. So there you go. I'm hoping that took less than 45 minutes. I believe it did. So now you should be working on homework number, let's go back to the beginning, 8, and your IA is due tomorrow. You want to make sure that it is in a state where you would feel like this is what they asked for. This is what the task asked for. I looked at the rubric and I looked at my checklist. And then the other thing I want you to do, I want you to grade your own. So when you bring it in, you should have a grade out of 20. So you decide what you think you've done and what you would give yourself. And then if I have time, I'll kind of go through and decide what your grade might be on my own too. All right. Thanks, guys. I'll see you tomorrow.